Hi, this is Roger Breton, and hopefully the audio from my microphone is fixed. And without further ado, let me dig into this piece of software that I want to demonstrate today through this short video. Um, First things first, let me just quickly explore the interface with you. This area here, this gray area, everything is gray here, by the way, because I didn't want to have any kinds of colors that would be distracting to whatever color that would be displayed here in this area. It's very important, but it's little things. I wish I could have, blues and greens and reds, but it's about color, and to appreciate color, you need some kind of gray. All right, so this is the application that you could install free from the provided link at the bottom of the video. And what this application does is to allow um, visualizing images. So let me start here. This is the most important area of the application, this load button. What this load button will do is to allow loading an image. Let me go here to my picture folder, and let's start with this image. This image is, for those who may have seen it before, it's an image corresponding to a uh, physical chart. It's a chart that's very popular in television and photography, uh, printing not so much, but in color management circles certainly. So it's called a color checker, and I have a whole story to tell about this chart. You can find more information by just typing color checker here on any search engine, and boy, will you be rewarded. Okay, so the first row, I'm not gonna go too much into the details or the structure of this chart. The point here is that this is an RGB image that I loaded through this button. So here's another, let me just change type. Here's another RGB image. You see, this one takes up almost the entire area over here. I wanted to give you as big an area as possible to view images because so this is a little birdie. Let's see what this birdie looks like. Oh, love the blues on this image. Now, are these too saturated? Are these the actual blues? Becomes a matter of taste. Now, what's interesting is where this area over here, which disclose some of the image properties. You can find out over here the base image property, which are BGR, which is blue, green, red. So it's Microsoft way of displaying the color format, 24-bit per pixels. It's an RGB image, and it has 617,303 bytes in length, and this is the pixel size of the image, 960 pixels wide by 540 pixels high. Any image here is automatically stretched, adjusted, or scale or shrunk to the size of this area. To appreciate the interface, you need to have uh, preferably a screen with 1350 pixels and by 1024 pixels. Anything that happens here gets logged. So for instance, I'll come back to this image. Oh, maybe this image. I'm not sure it's gonna load. Is it going to load? Yes, it will load. I like Batman and Robin. This brings me right into my childhood. See, over here, the last, just like a log, it gives you status. So it says sRGB profile assigned by default for color management purpose. And if you scroll up, you see uh, other messages that I send you as you are, progressing into the application. I'm gonna stop here just quickly. Okay, I'm back. I want to continue on this Batman image. This Batman, it looks in grayscale, but it's a really an RGB image. As you know, if the RGB components are equal to each other, it creates the appearance of gray. So this pull-down menu is interesting because that's where it's possible to control or to change the meaning of the pixel colors. And in this case, because it's an RGB image, there isn't any of these other profiles, that's how they're called. Right now, the sRGB profile is the one assigned by default to the image because no profile was found in the image. Let's see over here. This is image properties. If I scroll up or down over here, you don't see anything that says ICC profile. Let me load an image that has an ICC profile. Let me change directory or image type. Let me load this image. No. This image. Alright, this image. Now if I scroll down the image property list, look at that. All of a sudden we hit things that are called ICC something. ICC profile, profile size, profile type, profile version, class display, and so on. If you want to know a little more about this information, I recommend you my other video on ICC Profile Inspector, where I explain some of the basics of what an ICC profile contains. One of the most important, anyway, I'm not going to dwell on this, but profile description is probably one of the most important pieces of information, and it says over here ECI RGB version 2, which is exactly the information that appears over here. Now, all along here, the information, the pixel is displayed straight into the monitor space. Why? Because there's no color management going on. It's the raw pixels that are going straight to the video card. And from the video card, whatever the monitor does, if the monitor has any smarts, like having own video curves or lookup tables inside it, whatever the monitor does is whatever the monitor does with the pixel information, the RGB values that it receives through the wire. So in this instance, why I created this application is to allow you to visualize the effect of ICC profiles. Now, in a chain of ICC profile conversion, there's always what's called a source profile, and in this case, it's going to be this guy, ECI RGB version 2. And there will has to be what's called a destination profile. I have something that says destination profile over here, but that's not what it's about in this workflow. In this case, the destination profile is going to be the active display profile. This is, or let me just bring this over here quickly. Color management, no. I need to call out the color management control panel. So this is all the control panels. This is the color management control panel, and as you can see in the color management control panel, this is my device. It's a NEC Multisync PA271. That's the name of my monitor, and it's being driven by this NVIDIA GeForce GTX 645 video card. So underneath it, what the window does is it associates a profile with this device. You see that? And there's two profiles being listed here right now. I could have more if I click the add button, which is going to show me the content of profiles installed into my color folder. So not interested in adding any more profile. It's not gonna let me add just any kind of profile. Let's see if I can add Apple RGB. Let's see. It has Apple RGB, so I could very well designate Apple RGB as my default profile. Just do it, and that's it. It's become my default. But that's not what I want. The default profile I want to use is this guy. So I set it as the default, and this is the profile that appears over here as under active display profile. This is the system profile. Same thing on the Mac, same thing on any operating system, I guess. Let me quickly stop over here for a second. Okay, I'm back. I wanted to separate my video files into smaller ones, not having too long, just an old habit. Alright, so this is the raw appearance of the image. It will look different on any monitor. So the idea here is to sort of normalize or universalize or find some kind of common thread between any any uh, any monitors that any piece of hardware that could potentially display this image. So once I know what the destination profile is, and once I know what the source profile is, in other words, what colors are supposed to be represented over here, I can turn to this area of my interface to select a conversion, to trigger a conversion. So now there's no conversions. In other words, the colors are, like I said before, going straight to the monitor. How about if I trigger a relative colorimetric conversion to the screen? You'll see the color changes immediately. Now, between relative and absolute colorimetric may not be a big difference because of the white point that this profile represents. But other profiles, the difference will be bigger because also of the calibrated white point of my monitor. Let me load an image that actually has this image, for instance, the accordion player. The accordion player has an sRGB embedded profile. This was detected at the time of loading the image from file, and you can see over here it's going to show up as all the ICC profile information relative to this sRGB profile are shown up over here. Now what happens when I switch relative colorimetric? In other words, take the colors of the image and convert them to the destination profile, which is the monitor profile, through this rendering intent. So the colors look more accurate and more accurate. What about what happens? What about when I switch to absolute colorimetric? You see what happens? All the colors turn blue. Here they look sort of yellowish. Here they look sort of bluish. Relative colorimetric, absolute colorimetric. I'm not going to explain um, the the mechanics or the singularities of these profile conversions, but suffice to say for now that a sRGB or Adobe RGB profile, which all both share D65 bluish kind of white point, should look similar. There's differences between Adobe RGB and sRGB and the choice of primaries, but the white point is the same. So if I go to a 5000 degree kind of white point, you see the appearance is very different because the white point is one of the most important part or pieces of rendering colors inside of an ICC profile. So back to relative colorimetric, and now I want to demonstrate quickly. You can assign, as you saw, change the interpretation. You can also load a profile of your taste. Uh, what happens if I'm curious to know how the color would change under different monitor profile. So I have two extra buttons over here, profile test 1 and test 2. So let me load test 1. So I'm going to use this profile just for the sake of argument. And this is the name of the profile that comes up over here. This area is the object of a separate video. I'm not going to explain it here. This allows selecting a different monitor profile. So in effect, as you see over here, I can switch from the system profile, which is selected by default, to test 1 profile or test 2 profile, which are over here. And let me go back to, let me stay in sRGB, and let me go to relative colorimetric. So uh, relative colorimetric under system, this is how the color looks like. Under test 1, see it's a different monitor profile. The colors change slightly. How about under test 2? Test 1 and test 2 are very close to each other. See the difference? This one was made by ICCOne Profiler with the ICCOne Pro 2. And if I go to test 1, this was made by ICCOne Profiler, but measurements were provided by my Minolta CS200. So it creates different, different measurements. It will create different rendering of colors. And this is uh, another profiler called Argil, which I recommend you. Uh, and this is CS200. I have Argil with I1 Pro, but I'll show that some other time. So that's the idea, using more than one monitor profile to test the appearance of images. Now, I'm just going to demonstrate quickly a complete workflow if one is interested. So let me go to TIFF and hunt again for this image in lab. No, I'm not. If I load an image in lab, uh, it's going to get converted, but I don't have the control over the conversion, so I don't want to do that. Lab is not supported in my software for now. So let me go to this image, but this image looks interesting. Color map PNG. Oh, this does not happen. Support this probably has some transparency, so I cannot load this type of image in my application for now. Uh, how about this? How about this guy? Again, same thing. Uh, okay, can I get this image to load? Okay, so this image is loaded. And what if I want to convert it from the source, which is C2? C2 is Facebook profile, by the way. If you upload any image on Facebook and it comes out as C2, you know it's Facebook profile, which is very close to sRGB. I think it's the same thing. It just call it like that to avoid um, legal um, legal pursuit. All right, so I'm going to load a destination profile. And my destination profile could be anything, but RGB or CMYK. Let me load something that is striking. An IFRA profile, which is a newspaper profile, 246. And let me go for absolute colorimetric, just to hit you very well. So convert the destination now. I'm ready to do this. Convert from the source, which is C2, over to IFRA 26. Now at this point, the color is still not being managed to the display because under this interface, it shows that it's using none. So the CMYK colors are sent as RGB to my monitor profile, raw. So let me go to relative colorimetric, and now let me see what absolute colorimetric looks like. You see how dull and gray and Well, that's what life is in newspaper. They don't have a big range of color. Now, if I want to compare the original to this, I can always go back over here to source and use whatever profile I want, monitor profile I want to view the color and go back to the converted image. And ultimately, if I'm interested, I can save the file to an image, call it CMYK, and it's good. That's it for now. Keep an eye on the log, and hopefully the program does not crash too much for you. Thank you for watching.